What is input-output, I/O in basic automation? Imagine a factory where machines can sense their surroundings and respond automatically. How do they do that? The secret lies in how they communicate with the outside world. That's where input and output come into play. Think of input as the system's way of listening to sensors, and output as its way of talking to devices like motors or valves. When setting up simple automation, understanding this communication is key. In basic automation, input refers to signals from sensors that measure things like temperature, pressure, or position. These sensors send electrical signals to the controller, which is the brain of the system. For example, a temperature sensor might send a voltage signal when it detects a certain heat level. The controller reads this data to decide what to do next. Output, on the other hand, is how the controller acts on the information it receives. It sends signals to devices such as motors, relays, or valves. If the temperature gets too high, the controller might turn on a fan or open a cooling valve. These signals are electrical, and they tell the devices to perform specific actions. In industrial control systems, input and output modules connect sensors and actuators to the main controller. Input modules take signals from sensors and convert them into data the controller can understand. Output modules take commands from the controller and turn them into electrical signals that activate devices. This process makes the system respond in real time to changing conditions. For example, in a conveyor system, sensors detect if a product is present. The input module receives this signal and tells the controller. The controller then decides whether to turn on or stop the conveyor motor. The output module sends the command to start or stop the motor. This cycle keeps the process running smoothly without human help. In smart factories and Industry 4.0 setups, I/O systems are more advanced. They support digital communication protocols and network devices, making automation more flexible. Modern I/O modules can include features like signal conditioning, diagnostics, and compatibility with different communication standards. This allows seamless integration with supervisory control systems and data platforms. Practically, I/O is used to monitor production lines, control robotic arms, or operate valves based on sensor feedback. It also helps in safety by receiving emergency stop signals and shutting down equipment instantly. Data collected through I/O can be analyzed to improve processes or predict maintenance needs. In simple terms, input and output are the essential links that allow machines to sense their environment and act accordingly. They form the foundation of how industrial automation systems work. Without I/O, machines would be unable to communicate or respond to changes, making automation impossible. Whether in a small control panel or a large smart factory, understanding I/O is the first step toward effective automation setup.